Let's see the next topic in general science, that is atomic structure. This topic is very important in chemistry, and in all the competitive examination you will get one question from this chapter. Okay, so before going to the previous year question, let's see what are the important topics that you should go through before going to your exam. Okay, so the first one is atomic theory and its chronology. You should know what are the various theory proposed by various scientists and their timelines. Okay, afterward you should know about the facts about subatomic particle, which include electron, proton or neutron. Okay, and afterwards the characteristic of atom, and out of these, this atomic number, mass number, and based on these atomic number and mass number we have different types of element which we call it as isotope, isotone and isobar. Okay, all the definition you should know what is the difference between isotope and isotone and isobar. Okay, and afterward electronic configuration, like how many electrons are in L orbit or M orbit, that formula you should know before going to your exam. Okay, and finally there can be some numerical on finding the number of proton, neutron and electron. Okay, so in today's session we are going to have one or two questions from each of this topic. Okay, and I request to go through all these pointers that I am presenting in today's session. Okay, so let's see the first question, a very simple one. Who coined the term atom? Okay, the options are Antonio Lavoisier, Joseph Proust, Democritus and Dalton. Okay, so all of these personalities are related to atomic theory. Okay, and as you know, Antonio Lavoisier, who is also known as father of modern chemistry, he has proposed the law of conservation of mass. Okay, he has proposed law of conservation of mass. Okay, and whereas Joseph Proust is another scientist who proposed the law of constant proportion or constant ratio. Okay, law of constant proportion and constant ratio. Okay, then Democritus is a Greek philosopher who had coined this term atom. So answer for this question should be option C, Democritus. And Dalton, you should know that he is known as father of atomic theory, and he is the first person who proposed a theoretical model which become basis for all other model. Okay, so the answer C is the right answer. And we have seen all these pointer in our theory class where we discuss about the timeline, like it started with 600 BC, and you should be surprised to know that Kanad is one you can say astrophysicist, okay, who basically suggests that if you divide anything it become a state where you will not able to divide further. Okay, and that smallest entity is known as Parmanu, which is a Hindi word. Okay, so basically this is the personality who gave the first suggestion of atom, but he renamed it as a Parmanu. Okay, actually it is a Parmanu, but Democritus coined the term atom, that you should know. Okay, so if option come who have first found the atom, based on the option you should answer that. Okay, but generally in modern chemistry Democritus coined the term atom, that you should be very cautious. Okay, the next one, around 1808, like you should know that John Dalton proposed the atomic theory, and he has given some postulates which become foundation for all other theory which are given in the preceding year. Okay, afterwards we have seen J.J. Thomson, a great scientist who discovered electron by cathode ray experiment. And in 1904, again J.J. Thomson proposed plum boarding model that we have seen in our theory class. I am not going to discuss in today's session. Okay. And in 1911, afterwards, it is Rutherford who discovered nucleus by gold foil experiment. So we have discussed about gold foil experiment, how it discovered nucleus, why it discovered nucleus, all such pointer we have seen. And the most important one is the Neil Bohr model, which basically tells how many electrons are revolving in fixed orbit. So based on that, you have one questions in your exam. Okay. And in 1932, it is a James Chadwick who discovered the neutron. So this is a very important pointer which is generally asked in the exam. Okay. So all such things we have covered in our theory part. Okay. Let's see the next question. Who was the first one to propose a model for structure of atom? Okay. Okay, so there are many personalities who have given the structure of atom. The first one is a Dalton, but Dalton solid sphere model is just a theoretical one. Okay, although the further subatomic model are much relevant and they are able to explain few of the phenomena which was not described by the Dalton atomic theory. Okay, so before answering to this question, let's see a few of the model which has been evolved and we have studied in our theory class. The first and foremost is the J.J. Thomson plum pudding model, that is in year 1904. Okay, and it is considered as the first proposed model where he tells that every electron is embedded in a positive sphere. Okay, afterward Rutherford has given another model which tells that basically there is a lot of space and electrons are around the nucleus. Okay, but he does not tell that they are revolving around a fixed orbit, which was given by the Neil Bohr. Okay, that is in Bohr model in 1913. Okay, and afterwards, after the wave mechanical model, Erwin Schrödinger basically gives that instead the electrons are not revolving in the orbit, they are basically revolving in a orbital, s orbital or p orbital. Okay, and the position of electron is not fixed, it is basically decided by the wave function. Okay, so all such thing we have covered in our atomic model theory. Okay, so the answer for this previous year question, if you see, it is a J.J. Thomson who gave the first model, that is plum pudding model. Okay, so answer D is the correct answer. Okay, let's see the next question. Which British physicist was awarded with Nobel Prize in Physics in 1906 for his work on discovery of electron? Okay, so this is very important question, and as we have seen, J.J. Thomson not only discovered the electron but also the plum pudding model, which become the foundation for all other model. Okay, so basically it is the J.J. Thomson. What about James Chadwick? He had discovered neutron. These are the subatomic particles. Okay, and Neil Bohr give the model where he described that electrons are revolving in orbits like K, L, M, N orbits. Okay, and he tells the number of electrons which are found in these orbits. Okay, and J.J. Thomson discovered the electron, whereas Ernest Rutherford, he is considered to found the nucleus. Okay, nucleus is a core of the atom. Okay, which consists of proton and neutron. Okay, so answer C is the right answer. So we have seen there are different type of subatomic particle, and you should know what are the charges present on the each of these subatomic particle. Electron has negative charge, whereas proton has positive charge, neutron has no charge. Similarly, the mass of each of these small particle, okay, as you can see, it is 10 power minus 31, 10 minus 27, 10 power minus 27. Okay, so the mass is very less, and if you compare the mass of electron, it is far less than proton and neutron. The mass of proton and neutron is equal, okay, and that's why the atomic stability is there, positive and negative, so the atom become neutral in whole, okay. And location, if you see, proton and neutron are inside the nucleus, where electron are outside the nucleus. And we have seen J.J. Thomson discovered electron, Rutherford or Goldstein basically theorized the proton theory, okay, and James Chadwick is the person who found the neutron, okay. And the very important pointer which is generally asked in the exam, that which element has no neutrons, okay, so it is hydrogen. And if you see hydrogens mean its atomic number is 1, its mass number is 1, but there are no electron or no neutron, okay. So there are no neutron, 1 proton, 1 electron, okay. And it is the protium is one of isotope of hydrogen, so H11 hydrogen is the element which has no neutron in it, okay. Next question, in dash all subatomic particles are present except neutron. Just now I told you that it is a hydrogen protium, okay, hydrogen whose atomic number is 1 and mass number is 1, and it is one of the isotope of hydrogen which is known as protium, okay, just remember protium, okay. And the number of neutron, how we find it, it is basically mass number by minus atomic number, so it is number of neutron is 0, okay. So in hydrogen all the subatomic particles are present except neutron, okay. So option C is the right answer. The next one, nucleus contain dash percentage of mass of atom, okay. So basically an atom consists of 3 subatomic particles, electron, proton and neutron, okay. So this is an atom, so atom consists of a nucleus which contain neutron and proton, and electrons are revolving in orbits basically, okay. And we have seen the mass of the electron is almost 1 by 1836 of the mass of hydrogen atom, which is very small, okay. So it will not be 100%, it will be 99.98%, a very less than 100%, because mass of electron is very less, okay. So basically nucleus contain 99.98% of mass of atom, okay. Option C is the right answer. In the context of isotope of any element, which of the following statement is not correct, okay. So before answering to this question, let's see few of the pointers related to isotopes. So basically there are isotope, isobar and isotone, which are generally asked in the exam, and out of these isotope is very important concept, very important topic. So let's dig into it. So iso, whenever you find the word iso, it means the same. Tops means the place. So same place means what? It has the same place in the atomic periodic table, okay. So it occupies the same place in periodic table. How? Let's see. For example, you have heard there are different isotope of the carbon, say carbon 12, carbon 13, carbon 14. And if you see, the place of carbon will remain same in the periodic table, okay. So basically these are the atom of the same element, okay. So they have same atomic number. If I'm saying they have same atomic number, means they have same number of proton, but their masses are different, okay. That is very important, okay. So when I'm saying that they have same place means they have same atomic number. So if you know the definition of atomic number, it means the number of protons. So number of proton remains same, but they have different mass number, okay. And this is one fact that existence of isotope was first suggested by Frederick Soddy, which tells that the name should be isotope and it should occur in the periodic table, okay. And the two important characteristics of isotopes are that they have same chemical property. Why they have same chemical property? because they have same electronic configuration, because they have same number of valence electron. Okay, so you know that whenever there is a chemical reaction, it is the electron which participate in the reaction. Okay, and why they have different physical property? Because they have different mass. So if they have different mass, means they have different density, they have different melting point, and they have different boiling point as well. Okay, so remember, isotope have same chemical property and they have different physical property. Okay, and few of the examples which are commonly asked in the exam are the isotope hydrogen, carbon, scandium, uranium, cobalt, and iodine. Okay, so there are three isotopes which are found in the nature. First one is a protium, second one is the deuterium, third one is a tritium. Okay, so H1, H2, H3, it means that hydrogen atom with one atomic mass, H2 means 2 atomic mass, and 3 is the 3 atomic mass number. Okay, similarly carbon have 3 isotopes which are commonly found in nature, 12, 13, 14. Means if I am talking about C14, this one, it means that atomic number is 6, that is number of proton is 6, and the mass number is 14. Okay, and this C14, it is commonly asked in the exam, it is used in carbon dating. Okay, carbon dating is basically phenomena where you need to find the age of the fossil. Okay, so age of the fossil can be determined by carbon dating, in which carbon 14 is used. Okay, and scandium has most isotope, it is the 13 isotope. And if you talk about uranium, which is used in nuclear weapon, it has 3 isotope, U235, 238. Similarly cobalt is one isotope, is there, CO60, which is used to destroy the cancer cell, and iodine 131 is used to prevent goiter. Okay, so these are the few example of isotope which are asked in the exam. All such pointers we have covered in our theory classes. Okay, so let's answer the previous year question that we have skipped. So they have same atomic number. Yes, isotope means they have same atomic number. They differ in physical property. Yeah, they have different mass numbers, so their physical property will be different. So it is also true. They have same mass number. No, they have different mass number. Just now we have seen they have same atomic number but different mass number, and they have identical chemical property. Okay, so option C is the right answer. Let's see the next question. Isobars have what? Okay, so just now we have seen about isotope, and it is isobar. Okay, so the word iso, as I told you, it means same, bars mean weight. Basically bar mean the weight or mass. So you can say that if there are two elements which have same mass number, they are isobar. Okay, so they have same mass but different atomic number. Okay, same mass number but different atomic number. Okay, so option D, those who have given, they are good. And if you see the comparison that we have skipped in the previous slide, so basically iso means the same, as you can see. Tops means same place in periodic table, bar mean weight or mass, and tones mean the neutron. Okay, so in this case isotope, if you see, since they are occupying the same place in periodic table, means they have same atomic number. Similarly, if you talk about mass number, they will have different mass number, but the number of proton remains same. Why? Because atomic number is same, so this will remain same. And number of neutrons will be different. Why? Because mass number is basically the difference, number of neutron is basically the difference between atomic number and mass number, so it will be again different. And the chemical properties, as I told you, it will be similar, whereas physical property will be different. Okay, and you can see similarly about isobar and isotone. Okay, isotone have same number of neutron, whereas isobar have same mass number. Okay, and the example are argon 40, calcium 40, carbon 14, and nitrogen 15, which are best example for isobar and isotone. Okay, Let's see the next question. Which of the following pair of number composition are correct? Atomic number means number of proton. Mass number is sum of neutron and proton. Yes, atomic number, as I told you, that it is basically the number of proton which are present in atom. Okay, the mass number, it is basically the total mass of an atom excluding electron. It is sum of mass, number of proton and neutron. So both are correct. Okay, so those who have given option C, they are right. And we have seen about atomic number and mass number. I am not going to repeat in this slide because this is a very simple one. Atomic number means number of proton, mass number means the number of proton and neutron, and sometimes they are combined as known as nucleons. Okay, so that is mass number. Let's see the next question. What can be the conclusion found about the carbon atom C6C12? Okay, so you should know about the notation which is used. So let me show you the notation. Okay, so this is a standard notation which is used to find the relation between atomic number and mass number. So the subscript Z denote the atomic number, whereas this A represent the mass number. Okay, and shortcut notation is X dash A, means element minus A. For example, if I am talking about carbon which is having mass number of 12, so I am taking it as C12, and if I use the standard notation, it is C612. Why this shortcut notation is used? Because you know the symbol. So symbol, if you know, you can easily tell the atomic number. Okay, so the number of neutron, if you want to find out, it is this minus this. So mass number minus number of proton, or the atomic number, it is number of neutron. Okay, so let's see it. So if you see this notation, it means 6 is the number of proton. Why? Because it is represent the atomic number. Okay, 6 means 6 proton. Okay, so 6 proton is either this or this. So these two options are eliminated. And how many neutrons are there? It is atomic mass number minus this. Okay, 12 minus 6 is what? 6. So there are 6 neutron and 6 proton. Okay, so option D is the right answer. Let's see the next question. Again, in this question you find the number of neutron in the nucleus of this nuclide. Okay, as I told you, if you want to find the number of neutron in such notation, you subtract mass number minus atomic number. So if you take the difference of 242 and 94, it is 148. So the 148 is the number of neutrons which are present in plutonium. Okay, so the very huge number of neutrons are present in this plutonium. Let's see the last question of today's session. How many maximum electron can be in third or M sub shell? It is not shell, it is a typing mistake, it is sub shell. Okay, so if you see the formula which was given by the Bohr, it is 2 into n square. Okay, 2 into n square. So n is the maximum number, like orbit number. Okay, and it is the number of electron which can be present in that particular shell. So there is shell K, L, M, N. So it is 1, 2, 3, because he is talking about the third or M shell. Okay, so it is 3. So 2 into 3 square, which is 2 into 9, 9 2s are 18. Okay, so in M shell or third shell, it will be 18 number of electrons will be present. Student, you remember this formula. For RRB exam, this formula is very important. Okay, if you want to find the maximum number of electron present in any of the orbit, you remember this formula. This formula is going to help you. Okay, so thank you.